All right, so we're here for Ariel Neumann's dissertation defense. Welcome, everybody. This has been, what would you call it, a long and winding road. Ariel started in the group as a master's student, then a gig as a research scientist, and then a PhD PhD candidate. And along the way, we and a very large team built many different versions of the Cityscope platform, tested them around the world. Ariel was right at the center of that development, took the lead in some of our most important projects. What I should highlight with Ariel's thesis is it's obviously a documentation of his personal contribution, but it's also more than that. He took this opportunity to archive the history of Cityscope, and actually going back 22 years earlier to a project I did in the last century related to my Lou Kahn book and the various different tangible platforms we worked on, which eventually ended up what we now call Cityscope. So it's great to finally get to this point. And let me just say just a few words about what we'll do today. So Ariel will present for maybe 45 minutes. The committee will ask a few questions. And by the way, we have Esteban Moro here in the room, and we have Aran Ben Joseph also on the committee who is remote. So we'll take questions from the committee, then we'll open it up to the audience, both in the room and remote, for other questions. We'll then ask all of you to leave, and the committee will discuss how we did. Okay? It's all yours, Ariel.
Thank you so much, Kent. So thank you very much, Kent, for that introduction, and thank you all for being here today, either physically or remotely. Today I would like to present our work on the Cityscope platform. But before I do so, I would like to start with a quick story. So back in 2019, which I guess to most of you feels like ancient history these days, we held our annual City Science Summit in this beautiful Elbphilharmonie building in Hamburg, Germany. This was the celebration of over 5 years of collaboration with the Hafen City University, in which we've built a very successful City Science lab and created what I think were some of the best Cityscope projects to date, many of which I'll explore here today. But the reason I'm telling you this story is not because of what happened in that summit, but actually what happened 2 days after it ended. So in a pretty sharp contrast to the glamour of the Philharmonic building, Ronan and myself hopped on this very, 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 very low-cost EasyJet flight and traveled to Budapest, Hungary. We were given there the address of this very unassuming storefront in a suburban neighborhood of Budapest. And inside we met a small, very underfunded, nonprofit group of researchers, scientists, and designers very eager to make a change in their city. Just as a side note, they were so underfunded that in order to pay the rent for that storefront, they actually brew and sold their own architectural themed beer. But inside that place, we've seen a familiar sight. We've seen a large-scale Cityscope featured with urban data, interaction, and real-time analytics. And maybe more impressive was the fact that this group already conducted several public engagement with local stakeholders and government officials. I'm telling you this story because for me, this range between a well-established long-term collaboration in Hamburg and a bottom-up, open source and underfunded process in Budapest is what Cityscope is all about. So before we dive deeper, I just first want to introduce and thank my distinguished committee. Some of them are here, some are remote. So Professor Aran Ben Joseph, joining us remotely from Israel, is a professor of landscape architecture and urban planning, as well as a former head of the Department of Urban Studies and Planning at MIT. Professor Esteban Muro, who is a visiting professor at the Human Dynamics group here at the MIT Media Lab, as well as a professor at the Universidad Carlos III in Madrid. And last but necessarily not least, Kent Larson, who directs the City Science Research Group here at the MIT Media Lab. Today, I would like to focus on how Cityscope can support and even replace traditional planning processes. I will start by observing the current trends of mass urbanization and review some of the efforts to mitigate these challenges through a new urban process. I will then suggest Cityscope as one way to support these efforts and present a series of lab experiments and real-world deployments of the platform clustered under these 4 themes: insight, transformation, prediction, and consensus. And I will close with an outlook on a future urban process. To begin, in order to answer the question of why we need Cityscope, we first need to understand a larger paradigm shift in the world of urbanization in recent decades. As you all know, the world today, since 2010, is considered to be more urban than rural. We're standing now at a 55% threshold of urbanization. We're expected to reach 70 by 2030. There are many different reasons for urbanization. I'm not going to go through all of them, but I will quickly mention that cities do offer higher GDP, economic mobility, innovation potential, better health services, lower energy consumption, cultural enrichment, as well as political diversity and many, many others. But alongside the many advantages of urbanizations, we are also acknowledging that the process of rapidly creating urban environments is not always equally successful. Generally, we can view 2 different reactions to the pressure of mass urbanization. On the one hand, we have overdevelopment and total planning. And on the other hand, we're seeing informal urbanization. The first kind suggests total planning, in which rigid models of top-down urban development aim to solve all urbanization issues with a single action. On the other hand, we can observe organic evolution of informal settlements, mostly in proximity to well-established urban centers. Both of these models carry certain advantages as well as some challenges. For example, informal development tends to be flexible, agile, and community-driven, but is mostly ad hoc and does not scale well. On the other hand, total planning can be data-driven and evidence-based, but does not adhere well to the community needs. As a result, both of these extremes tend to reverse the many advantages of urban development due to stressed infrastructure, unequal distribution of resources, pollution, or economic stagnation. Now, over the past decade, many policymakers have acknowledged many of these issues and created a variety of policies in an effort to mitigate them. Most notably are the United Nations Urban Agenda, the UN Sustainable Development Goals, or the IPCC Urban Environmental Report. I'm not going to dive into each one of them, but I think important to mention is that all of these efforts do not focus on an effort to create a perfect urban solution. Instead, they promote a new urban process that takes the good from both worlds and is agile and flexible enough to confront urban challenges as they occur, while still being centered around an evidence-based and data-driven process, all the while offering a collaborative decision-making which empowers both experts and their communities. In short, the UN New Urban Agenda calls it a paradigm shift based on the science of cities. And so in this thesis, I would like to propose Cityscope, an urban modeling and simulation platform, as one depiction of this new urban process. Today, I will cluster the many different lab experiments and real-world deployments of the Cityscope platform into 4 themes: insight, transformation, prediction, and consensus, and will demonstrate how they supported this new urban process. Now, naturally, none of the projects I'll show here today covers all 4 edges or falls perfectly into one specific theme. Instead, they all inherit, learn, and evolve from one another, something that I'll try to also demonstrate today. So to begin, the first chapter deals with understanding the current and past state of the city through insight. As Eran writes, our ability to currently deeply understand the city has a bipolar effect in which both the observer and the observee are transformed. And in that spirit, one of our first Cityscope projects was actually an urban observatory, a 3-dimensional canvas set to observe the current state of the city, with different layers of information such as land use, road network, solar, or wind. But soon after, we've started a long-term collaboration with the city-state of Andorra, and were granted access to several years of countrywide location data from Cold Data Records, or CDR. CDR data allows us to observe movement and analyze behavior of many thousands of locals and visitors to the country on topics such as urban hotspots, traffic congestion, or the impact of large events such as the Tour de France and Cirque du Soleil. Following this work, Andorra granted us an access to higher resolution data known as radio network controllers, or RNC. Here, this data provided us with the ability to accurately get insight about the mobility patterns of both locals and visitors, and more specifically, we could start and ask questions such as, why do some urban places have the tendency to be more attractive, while others stand fully deserted? In order to answer this question, we first identified stay event and stay clusters. These are places in the city in which people from diverse origins and destination might choose to stay together for a longer period of time. We have selected stay clusters that were both large, diverse, and long-lasting in an effort to find places that are more attractive to the public. We then cross-referenced these clusters with about 20 different urban and spatial features, some of them such as amenities, urban form, and landscape elements, so that we can find which of these features have the strongest correlation to the presence of people in a certain place. Now, the model that we've provided pointed to certain features that are well correlated to the creation of highly active places. So, for example, the agglomeration of religion, food, or bus stops together, as well as those with negative impacts, such as schools or parks. Now, inversely, this method can start to point to urban places that have the tendency to form activity clusters around them. Later, we took both those CDR and RNC insights as a baseline to support urban transformation processes, which I'll explore in the next chapter. And finally, the last thing I would say about insights is that last year we have used a similar approach, this time in the context of COVID-19 in Andorra, in order to correlate between the spread of COVID cases and certain mobility patterns in order to find which of them contributed the most to the spread. If you're interested in this work, you should talk to Alex and Ronan from our team. So I want to conclude the first chapter, insights. They can help us to better understand the current state of the city, as well as, and I think that's the key point, narrow down the scope of potential future interventions. Nevertheless, actionable insights can only be achieved using accurate, consistent, and unbiased urban data, which is still a challenge. But how do we go from urban insights to an actual change? So the next chapter, transformation, is where we start to develop ways to propose, test, and iterate on future urban scenarios. Transformation is the essence of urban planning. But as Eran writes, today it is still very difficult to clearly envision future planning scenarios. Since the 1960s, researchers explored ways to envision yet to be built urban environments. This is from 1961, the first computer graphics in history that depicted driving through a planned highway. In 1962, Ivan Sutherland here at MIT revolutionized CAD and HCI with the Sketchpad tool. In 1970, Nicolas Negroponte and the Architectural Machine Group created SEEK, an AI robotic interface that designed a microcity made out of toy cubes. The design of this city was done in reaction to the chaos created by living gerbils. As for the success of this experiment, I'll quote Negroponte himself, SEEK actually tended to kill the gerbils. In the early 1980s, the Berkeley Environmental Simulation Laboratory built extremely detailed urban models and augmented them with computerized vision and environmental effects, rendering some of the most accurate urban simulations of its time. In the 1990s, Professor Hiroshi Ishii here from the Media Lab manifested tangible bits with a slew of tactile, real-time, and iterative design tools. Together with Eran, these tools matured into iterative city planning platforms promoting both real-time as well as collaborative design sessions. Along the same time, Kent, in his work celebrating Louis Kahn's unbuilt masterpieces, envisions tangible immersive interface for collaboration and engagement. So as you can clearly see, the seeds of Cityscope were planted over 7 decades ago. In 2013, here is Ken presenting the idea of a rapid prototyping platform for real-time urban analytics, which of course at that point was still an idea to come. And indeed, at first, static models made out of Lego were used to highlight different aspects of the city. The usage of this playful and unintimidating medium was supported by the ability to use its modularity for repetitive spatial analytics tasks. Following was the Urban Observatory, which I mentioned a couple of minutes ago, which visualized pre-computed urban analytics. But again, at that time, still could not react to a change. In order to create an iterative decision support system, we needed to find a way to modify the state of both the physical and computational city model. But before I explain how we do that, I first need to explain what is our fascination with a grid of square tiles. Why don't we simply resort to vector-based urban modeling as in most CAD tools today? So through multiple user studies, we have shown, and some of them I'll explore today, we have shown that an equally sized and repetitive tile system is both easy to interact with and reduce cognitive burden on our users. In fact, even when we created digital twins of Cityscope, we have seen the advantage of interacting, computing, and even training machine learning models on a rasterized representation of the city. This reductive representation helps to focus not on the design details, but instead on the overall spatial arrangement and programming of the site. Cityscope is, of course, not the only tile-based method for spatial analytics. We're familiar with geohashing, QuadKeys, Google S2, and Uber H3, all of which use uniformed spatial subdivision systems. And similarly, CFD, or computational fluid dynamics, often use what is known as simplified metageometries in order to reduce the complexity of input geometries into models. The process of converting a part of the city to the Cityscope grid starts with 3D rasterization of the site and programming of each tile using land use, activity, and other spatial properties. The Cityscope schema allows us for simple as well as more complex types, which combine different functions, land uses, and activities into a single 3D tile. And when many of these tiles are gridded together, the Cityscope grid is then ready for analysis. So we have seen the Cityscope schema and the grid, but how can this be used in order to evaluate urban transformation in real time? So let's simplify Cityscope into a pocket calculator. We will call the calculator button Cityscope user interface, the display Cityscope front end, and the calculation unit, which is usually hidden, Cityscope modules. Similarly, all Cityscope projects, both digital or physical, follow the same concept: UI, modules, and front end. When we dive deeper into this architecture, we can see how it can support a modular, flexible, and open-ended interaction, computation, as well as feedback. For example, Cityscope interaction can be extended to various interface and devices, from our traditional Lego-based interface, which uses computer vision to scan a grid of binary markers, all the way to an actuated or robotic interface like the Roboscope, which Thomas and Marcus from our team are now developing. We can also extend Cityscope interaction beyond the physical interface to include, for example, augmented, virtual, or mixed reality systems. With these, stakeholders or community members can still view, comment, or even co-create during a remote participatory planning session. In the middle of that schema, we have the Cityscope modules. Here, user interaction data is processed through different analysis modules, from mobility and energy to financial and behavioral models. Over the years, we have proposed different mechanisms to bridge between those different modules, which we have collectively called CDIO. Simply put, CDIO acts a bit like a 1920s phone operator, which listens, manages, logs, and queue calls from the different interfaces, modules, and devices across the ecosystem. And finally, the third section is the Cityscope feedback. Here, interaction and analysis computed by the modules are presented back to the users through different interfaces, from projection mapping on tangible user interfaces to handheld devices, or web applications. Back in 2018, we have started consolidating Cityscope interaction and feedback into a unified front-end system called Cityscope.js. This system is a web-based interface that allows users all around the world to quickly bootstrap Cityscope projects, interact with the grid, and visualize the results of Cityscope modules on any interface, from their phones all the way to large-scale tangible interfaces. So now that we have looked into the Cityscope ecosystem, I would like to demonstrate how it can support real-world urban transformation processes. So for my master thesis, I was building a Cityscope module that examined a highly abstract urban concept known as the zoning envelope. This is the legal terminology and framework that is determining the building's usage, form, bulk, as well as shape. These virtual envelopes emerged in the early days of mass urbanization in New York in an attempt to protect the city from exponential development. Within 1 decade, zoning quickly sprawled all across the country while creating endless paper trail and complex legal terminologies, which paradoxically resulted with stalled or otherwise informal development. The goal of this project was to codify the building code, or in other words, translate the abstract legal terminology into computational functions and methods so that the evaluation of new urban development could be done logically in respect to the current zoning laws and building code. This interactive zoning simulator evaluated the fitness of a proposed design to the current zoning laws and responded with issues, guidance, as well as recommendations. The system was then evaluated in an HCI study with a group of planners, architects, and members of the community in order to compare traditional planning sessions against the Cityscope process. The result of this study highlighted the advantage of an iterative, real-time, and the key point here is non-linear exploratory process over traditional planning. The full results of this study are documented in the written thesis, but I do, however, want to highlight this article by the Guardian Journal, who picked up on this project and asked, Lego, can the most analogous of toys really be a modern urban planning tool? And I encourage you to read this article, but I do want to highlight a comment for this article left by a username Undigested Matter, who I think perfectly summarized why we build Cityscope interaction the way we do. And they write, Lego favors a crude representation, much less about materials, form, texture, and construction. And I am signing off on everything this person was saying, but then this comment, of course, goes rogue like many other online comments. This is a clueless bit of likely motivated promotion from the Danish Lego monster. For the record, I didn't get anything from the Lego monster, so let's leave it with that. About a year later, we have redesigned this platform to evaluate a major redevelopment site in Cambridge called Volpi. Here, we have used Cityscope to investigate a range of urban transformations, from dynamic zoning to micro-housing to alternative mobility modes or energy models. We tested these transformations through a broader range of metrics and KPIs, from land use and spatial distribution of amenities, density and proximity, to more abstract indicators, such as innovation potential or cultural diversity. While many of these metrics were a placeholder for more accurate models in the future, and some of them I'll explore later, the main purpose of this platform was to promote the idea of a unified urban simulation system, which could eventually support many aspects of urban planning at once. In 2018, we got an opportunity to test this idea of a unified system for an urban design competition in Hamburg, Germany. As part of our collaboration with the city of Hamburg, we've been asked to build a Cityscope for high-stake design competition in a site called Grasbrook, a major post-industrial parcel which is close to the city center, designated as the city's future innovation and entrepreneurship hub with about 3,000 housing units and 16,000 jobs. The goal of this competition was to attract the leading design teams from all over the world, and Cityscope was then introduced as a way for the city, decision makers, as well as the design teams themselves, to rigorously evaluate their design proposals through the same set of metrics and KPIs. In other words, Cityscope reduced each proposal to its rudiments in order to perform apples-to-apples comparison for the same KPIs, metrics, and models. More specifically, we have tested each proposal against 4 requested modules: noise, access, stormwater runoff, and GFA. When we later compared the results of these modules against analysis that was made by the consultants, our models performed either the same or better for noise, water, and access, despite running in near real time. Now, Kent titled this project as Reinventing the Competition, because unlike traditional design competitions, here, all proposals had to be evaluated equally beyond the rendering, visuals, models, or the fame of the selected architect. Nevertheless, I want to highlight a couple of, I would say, missed opportunities here with this work. One was that we were not able to create a public engagement process around the winning proposal. COVID had to do with that. But additionally, we focused in this work mostly on modeling and simulating hard urban systems, such as noise or access, but did not examine more subtle and implicit urban features. And I hope that the next 2 chapters would address some of these shortcomings. Just as a closing example to this chapter, in 2019, we merged many of these interaction ideas into a single artistic installation that discussed 2 extremes of an urban mobility future. This work was presented in the Cooper Hewitt Museum, and I'm not going to go in details here. If you are interested, you should talk to Gabi from our team, who is positioning us on the world's arts map recently, as well as with Carson Inasushi, who worked on this project. But I do want you to focus for a second on this video, because I think it nicely depicts that eureka moment where users discover how Cityscope interaction work. And for me, these moments solidify the advantage of making urban HCI technologies almost transparent as a backdrop for decision-making and public discourse. So to conclude the second chapter, urban HCI systems are useful to test potential interventions and observe some of the trade-offs they bring. Nevertheless, it's important to emphasize that these are not design systems per se and can only help to pre-plan and highlight edge cases. And lastly, in order to holistically understand urban transformation, we should also aim to assess more implicit aspects of the city. And so the third chapter, Prediction, discusses Cityscope models and modules that are designed to evaluate urban change in more subtle and gray areas. As you have seen clearly by now, Cityscope is well suited to model hard urban systems, such as shadow, noise, water, urban form, or accessibility. But in recent years, we have moved to model and simulate more implicit urban systems. The Volpe project, which I've mentioned before, was one of our early attempts to explore this range of hard to soft forecasting within a single Cityscope system. Similarly, the Reverse Urbanism project correlated human dynamics with urban features to explain implicit decisions of urban dwellers. More later work, such as the Mode Choice Prediction Module, or MOCHO, was designed to predict the impacts of micro-scale land use transformation on the mobility mode choice of entry behaviors of commuters all across the metro area. Here, users designed a very small portion of a neighborhood, and MOCHO was trying to simulate the origin, destination, and selected mobility modes of commuters to and from that site. With each user interaction, a synthetic population model would update to simulate both the mobility mode choice and the activity of each simulated individual, using a classifier trained on census and mobility survey data. In 2020, as part of our collaboration with the Ford company, a more advanced version of that model was developed for the Corktown site in Detroit. Here, again, an agent-based simulation was trained on census, POMS, and HTS, and other spatial data to simulate trips and mobility modes, choices, and changes given a transformation. An agent-based simulation, which I mentioned before, or ABM, can help assess the impact of more specific urban changes. For example, in Hamburg, an ABM was used to simulate the impact of micro-interventions, such as new circulation within a train station or the location of a specific bus stop, on the mobility habits of many maritime tourists. A similar ABM was used last year to examine a new master plan for the Champs-Élysées Boulevard in Paris. which included new amenities, improved public and green spaces, reduced motorized traffic, pollution, as well as emission. But a different flavor of implicit predictions look into how the image of the city can affect its inhabitants. Back in 1960, MIT professor Kevin Lynch introduced the idea of imageability as a way to understand and evaluate cities through visual perception. More recent work, such as StreetScore or PlacePulse, here from the Media Lab, quantifies street views for what makes them look safe, lively, or otherwise depressing or even dangerous. Nevertheless, early-stage city planning usually include only very crude and basic representation of the city, which is making it very hard for professionals and the public alike to envision how the city might eventually look like. So the DeepScope was a Cityscope module that uses generative adversarial networks to generate realistic street views during an early urban design and planning session. DeepScope is designed for a collaborative process in which diverse stakeholders can explore both the functional as well as the visual trade-offs of a future master plan. As users design the site layout using a tangible interface, their visual environment is populated with infrastructure and urban features. It is then fed into a Pix2Pix GAN model that draws a street view, which is then presented back to the designers during the planning session. More upcoming work in this field, which is directed by Esteban, brings together urban dynamics with street views in order to assess the impact of imageability on the experience diversity of visitors to the city. To conclude the third chapter, more subtle and implicit models can hint to how people will eventually experience the city after its transformation. Now, naturally, and I think I cannot emphasize that more, these models are hard to construct and are complicated to validate, as they heavily rely on soft aspects of the city, such as cultural, social, and temporal events. Nevertheless, with more data and better modeling techniques, subtle predictions can eventually become more pivotal in city planning. The last chapter, and probably the most impactful one, deals with using Cityscope for participation and building consensus among stakeholders. From a legal standpoint, public participation in planning processes was already mandated around 6 decades ago. Nevertheless, many cities bypass these requirements while maintaining a top-down and heavily bureaucratic and slow process, which tends to limit public input to mere tokenism or just simply venting sessions. In 1969, Sherry Arnstein introduced the ladder of participation, which simply put demonstrated that even seemingly participatory processes are, in most cases, stuck in the lower rungs of the ladder. In order to climb up this ladder, we can adopt 2 approaches. First are known as citizen experts, which are well-informed, active, and engaged public participants. The other one is collaborative participation, in which both the tools, the data, and the methods themselves are open for questioning and even criticism. So the last 2 projects I would like to share with you here today deal with these 2 approaches in an effort to create both citizen experts as well as collaborative participation. One of our first real-world out-of-the-lab experiments with Cityscope participation was the Boston BRT project. BRT, or Bus Rapid Transit, are enhanced mass transit systems that bring together dedicated lanes, prepayment, and improved bus stops to offer cost-effective alternative to public transportation. In the city of Boston, 5 of these routes were suggested. Most of them were planned to meet in Dudley Square area in Roxbury. Once a vibrant and well-served and connected community, the relocation of the MBTA Orange Line in the 1980s contributed to an ongoing decline of that area, creating resentment against major transit projects. Now, this is a disclaimer. The next slide might be a bit intriguing, but no worries. This lady is in a good shape. She's voicing her mistrust as part of an ongoing protest against large MBTA projects in the city. This was very much the atmosphere that brought the City of Boston and the Bauer Foundation to ask us to help create a community outreach process in the center of Dudley Square. Our task here was not to plan a new BRT solution, but instead to build a co-creation and learning process that could eventually help reach consensus with local stakeholders. One key aspect of creating what I mentioned as citizen experts was to engage the community members from the start as contributors, co-creators, and mentors, instead of just presenting them with the final results. And indeed, through these conversations, we learned, for example, that in order to clarify the impacts of the BRT, this project requires a multi-platform setup with different scales. The regional scale was designed to offer a citywide understanding of the BRT system and its impact on each member of the community. Here, participants would be able to design their own daily commute, and then were given insights on waiting time, access to housing, jobs, and amenities, as well as potential budgeting increase and even tax changes. The neighborhood scale used tangible user interface to define the most suitable locations to the BRT station in the vicinity of the Roxbury neighborhood, while presenting feedback on commuting time, pollution, and cost of each counterfactual scenario. And lastly, the street scale introduced the physical aspects of a BRT system. It showed how different BRT tiers would impact the urban design of a common streetscape, as well as how each BRT tier would affect the mobility performance in the area. In order to evaluate the learning outcomes, participants in the engagement sessions were given entry and exit surveys to compare their experience and takeout. Overall, both experts and non-experts alike demonstrated between 25 to 35% increase in their knowledge, and I think most importantly, ability to make better decisions in this topic as the time comes. The rest of the evaluation of this study is explored in the written thesis, but I do want to mention that this project was somewhat pivotal for the Cityscope team because it required us for the first time to leave the warm confines of this building and test many of our assumptions, methods, and tools in the wild. So the last project I will show today puts many of these assumptions into their, I think, greatest test. So a few weeks after the completion of the BRT project in Boston, we've received an invite from the German government to strike a collaboration between the Media Lab and the city of Hamburg in the Hafen City University. At first, we were asked to work on the upscale development of the Alba riverfront, as well as on the design of the Olympic Village, part of Hamburg's Olympic bid in 2016. But as all of you might know, by the end of 2015, many of these first world problems have to be put on hold since the immigration wave from Syria and Africa was expected to bring nearly 80,000 refugees and asylum seekers by the end of 2016. These are about 500 people a day for which the German cities and government had no viable solutions and only relied on ad hoc responses. As a result of this pressure, the public sentiment also changed. Following a failed Olympic referendum in late 2015, the mayor-owned government also became uncertain. A few weeks later, the mayor himself appeared in our newly established lab and asked for an out-of-the-box solutions for that refugee issue while posing only 3 major criteria. This has to be a bottom-up, a citywide, and a collaborative process. For perspective, our lab at the time included these 3 full-time researchers, and our space was only being set up. But within a few weeks, both the MIT and Hafen City University teams created a new Cityscope process, which was structured around an interactive exploration of housing solutions. And with perfect German accuracy, exactly 3 months later, the Finding Places was inaugurated by the mayor, as you can see here, holding the first Lego brick. Over the next coming months, we hosted about 30 community engagement events with over 400 participants. Target demographics and members of the community from affected areas were invited to this section. The Die Zeit newspaper called this opportunity swarm intelligence, doing instead of complaining. A typical Finding Places session would include introduction and insights into the current state of refugee housing in Hamburg, such as the current housing solution and the designated areas for future housing. From there, the group would transfer into an interactive neighborhood scale Cityscope on which Lego bricks would mark the addition of refugee housing to a site. This tangible interface translated interactions into GIS features which initiated analysis on all three scales: the city, the district, and the selected neighborhood. With each interaction, feedback on land contamination, zoning restrictions, lack of amenities, and access would show. By the end of this session, each team would share their feedback and compare with previous teams on how many places they literally managed to find. Now, overall, Finding Places had a measured outreach of 1.2 million residents with over 160 sites that were found for refugee housing by the public. Following further evaluation by the authorities, several of these sites were approved for construction, all the while community meetings were still taking place. Olaf Scholz, who is at the time the mayor of Hamburg and currently is the chancellor of Germany, described Finding Places by saying, "It is not just a theoretical task, but a task that our city has to solve together. Finding Places is your chance to examine whether what makes sense in theory is also suitable in practice." In the following years, Finding Places became a renowned example for building consensus in highly complicated decision-making processes. But unfortunately, as I recently heard from our German counterparts, the last few months demonstrated that Finding Places might become relevant again with the current wave of 4 million refugees flooding cities all across Europe. To conclude the last chapter, consensus is a critical part of modern and democratic urban decision-making. Nevertheless, new technologies and methods cannot fully replace true consensus building. They instead might mask non-democratic processes with only the optics of collaboration. In order to reach true consensus, both the tools, the methods, and the questions themselves should become open for discussion and even criticism. Finally, instead of a typical conclusion chapter, I would like to use the last couple of minutes here to share a utopian outlook. So when it comes to cities, utopia, or in some cases dystopia, usually comes in the form of extravagant master plans, from the ideal city of the Renaissance to Walt Disney's experimental prototype community of tomorrow, or Epcot, all the way to the techno-utopian cities of today. But what if the utopia we should aim for is not of a perfect city, but instead of a better process of city making? What if, for example, collecting urban data and insights goes beyond the desperate knock on your door once a decade during census, but is also not a borderline legal hijacking of location data from your cell phone? What if we construct voluntary, open, and transparent means of real-time urban insights which carry clear outcomes as well as accountable benefits? What if the knowledge graph of our city is always on? Beyond the typical traffic and sewage measurement, what if we always highlighting weaknesses, threats, and opportunities for both hard and soft urban systems? What if, beyond sensing and measuring the city, we also constantly hallucinate plausible urban transformations, from zoning changes to building codes to alternative energy sources or mobility modes? What if the process of urban decision-making is not just seeking consensus as an aftermath, but instead is designed and centered around the idea of collaborative participation? And finally, what if we go beyond smart cities and instead choose street knowledge to govern the wonderful mess cities could and should be? So to conclude, we've started by observing the current state of global mass urbanization. We then reviewed efforts to mitigate these challenges through a new urban process. We have explored how Cityscope can manifest this new urban process in a series of lab experiments and real-world deployments, and described how it supported, enhanced, and sometimes even replaced traditional planning and decision-making processes, hopefully affecting both the urban process as well as its outcomes. Before we go into a discussion, I would like to add just one more thing. As many of you know, in the past few years, we've been creating a network of city science labs all around the world, from South America to Middle East to Europe and to Southeast Asia. Many of these city science labs are built around the ideas of Cityscope as one of their main drivers for innovation, research, education, and discussion. So I'm therefore very happy to share with you that a few weeks ago, the Israeli government approved the establishment of a new MIT City Science Lab in the south of Israel in an area called the Negev. And I do want to quote from the government resolution because I believe it emphasized many of the things we talked about here today. We will establish an innovative national laboratory for the advancement of spatial, regional, and urban issues using advanced technologies and public participation. At the moment, we call it NUR, which is the initials of Negev Urban Research, and also doubles in Hebrew and Arabic as bright light, which, to those of you familiar with this part of the world, is the most governing environmental element. So I could not hope for a better conclusion of this work, and I can only hope that some of the ideas mentioned here today will find their way into this lab and to the future work we will do. And with that, I would like to once again thank you all very, very much and open this floor for conversation.
Okay, well, Ariel, first of all, thanks for putting together such a beautiful, well-conceived presentation. It's just, fabulous to see all that. I have a question that relates to what might come next. So, from the very beginning, we thought of Cityscope as a kind of, as we talked about at the Members Week a couple of days ago, a kind of extended intelligence platform. You know, the idea is that you allow humans to do what they do best, think creatively, express their values, discuss, bring in their own life experiences, but empowered by what machines do best, which is to process information and simulation and potentially generate solutions that humans would not conceive of. But it's not clear the best way to do that. So, and there are a number of ways to do that. So the Hamburg and Bar project is the idea that humans basically have full control. They can try anything, and then they get feedback. You know, the challenge with that is if particularly with lay people, if the problems are very complicated, they may not know where to begin. You know, they have to try so many things that it could become overwhelming. The second way to do it, which we've tried upstairs, this was Ryan's thesis, is you develop an AI system that anticipates what people might want to do and makes suggestions which then the human can accept or reject. The problem with that, as we found, it becomes kind of a video game and they don't actually learn anything. They just follow what the machine's recommending. The third way is, we also prototyped in the lab recently, is a generative system that can look at a whole bunch of solutions. People can then start with the one that seems to conform with their values, and then they take over and they refine it. So looking forward to future work, which of these strategies or others do you think have the most potential?
Right. I actually thought you were going to ask a different thing, is what is the fifth chapter of this work, which is usually our conversation beyond consensus if we go to governance.
And you can answer it that way too.
Yeah, and I guess it relates to that because to some degree, I think like any other tool, that the power of Cityscope is about automating and expediting processes that traditionally were very, very slow, very linear, and very challenging. I think that all the three methods you mentioned can achieve some of that to some degree. They can, the generative system can basically eliminate many of the options you otherwise would spend a lot of time finding. The machine learning help is similar. It's kind of AI on the shoulders that helps you to navigate through the many options. And of course, just the simple exploration of traditional Cityscope also help you to eliminate quite quickly. I think the major challenge, and this is what we saw very clearly with the BAR and the Finding Places project, was what is the question we're actually asking. So what it is that we are trying to solve. Because those tools, like any other tools, can only help you if the question is extremely clear and well-defined and on point. And I think that we saw that in many of the Cityscope depictions that weren't, Cityscope projects that were not as successful as Finding Places, the question was not very clear. So that we created a fascinating system, but it couldn't really help us to get anywhere because it's just, a quicker answer to a question you haven't asked. And so this goes back to the government conversation we have, in which if we build mechanisms that know how to ask the right questions and then focus them into what a tool can help us, Cityscope in any of these three criteria could help us be better planners. I think it happened in Finding Places, I think it happened in the BAR project, and I think in some other, future project potentially in Israel, these questions will be focused more clearly on problems that need to be solved in an automated and optimized way.
Well, so you mentioned governance. Let me just ask a follow-up.
Yeah.
So I see our Cityscope work as really the first phase of what will have many phases. And the next phase in my mind is to go beyond what these are tending to do, which is to figure out what would be the right thing to do, and move to governance to develop the processes that can trigger or facilitate the transformation. Harnessing market forces, dynamic zoning, all of the things we talk about. What would you like to work on to take it to that next phase if you had more time? Which, by the way, I think you will have.
I think the last 2 minutes were somewhat of a vision of where I would like this to go. And in a short sentence, I would say embed some of these ideas not at the end of a process like we tend to do. The government is hitting a wall and then they call us to build a Cityscope that expedite a broken process. But otherwise, elevate these ideas into the get-go of the government process and make sure and kind of put our efforts into instilling these ideas into the processes the governments are building from the get-go. If we can do that, then we might not even need Cityscope at the end, because the process itself will already inherit those ideas inherently. So that's very much where I would like to go, and this is why I think the quote from the Israeli decision kind of nailed it on the spot, understanding the two forces that are there. Not just computers and not just people, but sort of a merger between the two.
Okay, I think it's my turn. So I think I made a joke before the thesis that I was going to make 3 comments and a question, and actually that's actually what I'm going to do. So the first comment says to congratulate you for the thesis. I think the document that you put together and the presentation is top-notch, is high quality. I mean, I never seen a thesis that is so well framed. I mean, most of us, including mine, was just a compilation of papers, but you really made a whole document that can be reused after the thesis. That I want to congratulate you. The second thing is that I want to congratulate you again, because this book has a hard time. I mean, getting together this thing during the COVID times, it was. I mean, I feel sorry for all you guys that have to go through all these 2 years of the final part of your PhD thesis in a pandemic. And the other comment was about the initial tension that you mentioned in the presentation about the local versus the more, let's say, global solutions for the city. And I wanted to comment about, it might be just a scale thing, like you need, for example, when you think about a city like New York, a metro area, the tri-state, for example, metro area, you need probably an approach which is more global. And when you have to actually implement those solutions locally, you need an approach which is more, I don't know, like Cityscope will be more local and more participatory, et cetera. So I want you to comment on that. If it's just a matter of scale, or you really see that Cityscope can be at different scales?
Yeah, it's a great question. I think we tried many scales over the years, and we were sort of trying to see what are the edges of the system, when it becomes useful and when not. I think we saw pretty clearly that Cityscope is best suited for a neighborhood. It's not a city, it's a neighborhood scale, where it's tactile enough to make spatial decisions. In a regional scale, sometimes the places of things is almost irrelevant, right? It's more about the fact that they exist in some kind of a structure. But in the neighborhood, it's critical. Right? If you have things that are all pushed towards one end or pushed towards the other end, the neighborhood would be dysfunctional. And so the spatial aspect is very, very important. And it's also about the ability of people to actually recognize what happens when things are changing. We saw it in the BAR project, for example, where the city scale, which was the entire Boston metro area, was very hard for people to understand in terms of what it means to move a train station or a bus station from one place to another. Where when they jumped into the smaller scales, it was clear to them what are the impacts and the trade-offs of doing something like that. So I think at least, in my view, it's not that Cityscope is not suited for those scales, it's just about how you make sure that the impacts to those scales are clear as in the neighborhood scale. I think Kent is always mentioning the Andorra project we've done, where we actually focused on the Andorra La Vella, which is it's a city, but it's a neighborhood in its scale. We also showed sort of the resonating effect on other cities around it in kind of a different visual pattern, and that was communicating the fact that if you're making a change here, that actually have a resonating effect on those areas outside.
Yeah, I clearly agree that I clearly see that there is scales matter here, the kind of things that you can do. You cannot, for example, ask an individual to know, how is traffic in the whole city and how it's going to be affected. So you need the scale. My other comment is about risk, about uncertainty. I come from the modeling community, so that's my only expertise here. Most of the models that you use in for example, the agent-based modeling, the logistic regressions that you have in some parts, in MoCo, they have uncertainty. Mm-hmm. But the way you build the Cityscope is built more on the some kind of metric that I want. And I also have, I've been working on these models, and one of the things that people don't understand is probability. Mm-hmm. People don't, you tell them that it's going to rain today with 80% probability, they don't know what to do with them. They need to know whether it's going to be raining or not.
You take 80% umbrella with you.
Yeah, 80% of umbrella. So how do you, in your experience with Cityscope, how you communicate that uncertainty and how people cope with, even the decision makers, how do they cope with that?
Yeah, no, it's a great question. It's an ongoing, to those of you who are not familiar, it's an ongoing conversation between Esteban and me, where I listen and he teaches me over the past 4 years about those challenges. I'm, as you mentioned, not coming from this world, so for me, that was a great exposure into this whole world of statistical thinking and probability and the likes. I have a slide for you. So here's. We have seen this slide before.
This was not prepared.
That's not prepared, no. Haven't discussed that. I like these two quotes because I think to some degree they're starting to hint towards the conversation we traditionally have. So the first one is from a later paper talking about the predictability of a person roaming between different cellular towers, or CDR, locations that we discussed before, but I actually want to look into the second one because I think it's a very interesting quote, and it's from 1994. The quintessential unity of traveling instincts around the world. So when Marchetti is writing it and eventually becoming the Marchetti, what known as the Marchetti constant, which defines how much we're willing to drive every day for work, which is capped at about 30 minutes, he's actually saying this is relevant for the entire world, not just for a city or a specific region, but from the data I collected, and this paper was well cited later, defines a pattern of movement. And I'm using that as sort of a segue to sort of start and answer what you've been referring to, in a sense that we are not able, in those ABMs or in all of our models, to pinpoint a certain individual and say that's how that person would work, would move or would behave in the city. Or even larger groups than that is completely challenging to do. But I do think we can start and talk about distributions within the data that we have and within even the predictive models that we're creating. And in some of the work we've been doing together, we're seeing that it's getting closer and closer in terms of how many demographic distributions we can break the data to and how many behavioral distributions we can break the data to. And eventually we get to the point where it's becoming a very good representation of how people behave. Saying all of that, if we're building a very good descriptive model of human behavior, our ability to then build a counterfactual from that is not very linear, right? If I take a certain population and only let the others run around, that doesn't mean that we can truly predict the change in the city. But I do think that it means that we have a good enough representation of the current state and on, let's say, simple potential future states. How to communicate that? I think it's an open question. There is no one simple way. Visually, if you put an agent in the simulation, it's there. So it's very hard to say it's not really there. But I think it's part of the ongoing work of finding good ways to communicate that uncertainty.
Okay, I'd like to ask Eran if he has any questions or comments for Ariel.
Sure, thank you. I hope you can hear me. Can hear me okay?
Yeah.
Yeah, thanks. Well, thank you so much, and thank you, Ariel, for having me as a partner in your long and winding yet tangible road. In the last almost decade, I think your first email to me was in 2013 about Kendall Square, I think. So, again, wonderful work and amazing job. So, two things I wanted to ask you, and one is if you can, and maybe that goes back to what Kent asked about the process of planning, and how do you see it, and where does exactly the Cityscope builds into it, and what will be the next step after, let's say, consensus, as you said, is maybe reached? That's one. Second, if you can talk a little bit about the lesson that you learned, the limitation, particularly, I think, as you mentioned, the masking of consensus and the kind of critical view and the limitation of that with regard to Cityscope, if you can really talk about that and how you deal with that. And lastly, also what Esteban said, my third question would be about the Negev and scale. And, it's called Cityscope, I think, for a reason. But what do you do in a place such as a region where the threat for areas and planning for areas are not cities and not urban, and there is nobody who maybe speaks on behalf of the natural processes, the animals, the ecological system, and how does that actually works in a place like that?
Right. Thank you very much, Eran. I'll try to answer all of them sort of at once, if possible, but do stop me if I'm missing something. To some degree, I think it goes back to the discussion about that fifth chapter, that governance chapter, and where Cityscope can, to some degree, embed itself into the different parts of the urban process as they are today. I think that what we have seen in all of our projects is that when governments are sort of hitting a wall or a challenge with their current process, that's when they come to us to get some help. I hope, and I would like to see Cityscope being, or at least Cityscope thinking, being embedded in earlier processes or earlier stages in the urban process without the need to directly talk to us. So I mentioned in the last part, for example, collecting data as a given, right? Not just when we have a project, but as kind of an ongoing system of data collection, which is voluntary and secure and safe. And there are many, many people in this building working on technologies that can make it private, as well as hallucinating transformations. So not just starting commissioning somebody to do a planning study on some region, but having systems, and again, using the technologies we have today, to always think about what is the potential change given the data that we already collected. And finally, again, building consensus as ideally part of the whole process. So not reaching consensus, as it is today, and especially in Israel, we have, 10 years of planning, and then we start calling the local communities to come and voice their opinion, but that's a very, very late stage in that process. What if we, from day one, have ways and mechanisms, and again, using technology, mechanisms to engage communities and the public alike? So for me, the kind of the fifth aspect of Cityscope is how do we plug all of these ideas directly back into the process? And just on the last comment about the Negev, we'll have to, I think, when we hit the ground running, we will have to see how we fit or meet Cityscope in that region. It's definitely a different region. But I agree with you that Cityscope is a city-first kind of system. It's meant to look into existing neighborhoods or existing places and kind of find the right balancing of transformations and interventions in those areas. When it comes to larger scale, we'll have to find ways to do that. One thing I would say, and that maybe kind of tapping into other research topics we have in our group, it's about also finding new ways of collecting and understanding the place, right? Creating mechanisms to better understand the region, and we have teams here working on sensors and then other mechanisms to understand places which are not falling into the way urban insights are being collected. So I believe that there is a room there to explore some of these questions. But again, it's an open question. When we face those communities which are usually don't have a voice and are not put in the public process, we'll have to find new ways to either collect data about them or communicate to them directly.
Okay. Well, maybe we should open it up to people in the room or online if anybody has any questions. Katja. Here.
Thank you. Thank you, Ariel, for the presentation and all the great work. What I found particularly interesting is that you consistently showed the insights you generated or the insights that Cityscope generated for people you interacted with and the learnings and the surprises. So for me, knowing you as a recovering architect, what's your most surprising insights? What is your changed idea during this PhD that you take with you after 6 years to 10 years?
Yeah,
you can give me 3, of course, but that changed the insight in your own thinking.
I was about to say you should ask me after the beer, and then that will be
I will.
That will be a better answer. But I would say that, and this is something that taps into what Ines and Arnstein are talking a lot about in the context of public engagement, is that the assumption that the masses are incapable, which was the prevailing assumption for many decades, is beyond wrong, right? The main problem for many years was to create channels of communication which are not in the form of traditional public engagement, which usually means flipping tables, after 3 hours of a bad conversation. But it's actually listening and finding ways to understand their needs. And for me, doing many of these Cityscope projects, when we created the right vehicles for those communications, the public is as intelligent as us, if not more. They know their place, they know where they are, they know what they need. They just needed a large megaphone or kind of a vehicle to communicate their desire. So for me, that was, I think, the biggest taking here is about creating systems and ways to allow people to vocalize their opinion and their needs and become really partners in that urban process. But again, ask me after the beer again.
Another question here or a question online?
I think there are some textual questions. Maybe.
I just see a question coming up from Rachel. Rachel, do you want to go ahead and unmute and ask?
Hi, sure, thank you. I'm just really curious with, accelerated climate change impacts to cities and that to what extent climate and earth system data has a role in your models. And I'm curious about exploring the idea of, urban climate resiliency and citizen engagement around climate change with your process.
Right, thank you. So that's a great question. It's a great segue also to the work we're planning to do next because, again, the Negev is in the south of Israel and is in the global south of the world. And much of the work we've been doing in the past few years is about those regions, which are the first to be affected by climate change. I didn't mention all of that work, but there is a lot of work in the context of Cityscope and energy. We've done work in Andorra, in a sense, which was led by Luis, targeting ways to create kind of energy autonomy, if that's kind of the proper term, how do we basically make this city-state and resilient in terms of their energy consumption. We've done work in South America about, again, finding new modes of energy, and I think there is a course taking place right now talking exactly about those questions, so there is quite a lot of work. I would say, however, that maybe that's a bit of a challenged statement here, but I do believe that many of the ideas that Cityscope was touching upon in the early days, just thinking about the right set of neighborhood and the right set of spatial organization, already internally answer many of the questions that are related to energy. Because when we live in a condensed way, when we live close to each other, when we have good distribution of amenities, functions, mobility modes, etc., we are inherently answering many of the problems that are related to the energy and to the climate change. Nevertheless, there is, again, a lot of ongoing work, and the future is open in that field.
A couple in-person questions.
Hi, can you hear me? Ariel, thank you very much for this amazing presentation.
Who are you?
My name is Marcus.
Yeah. That's Marcus' computer. This would not happen without Marcus's computer. So.
I have two questions about community engagement and how agnostic the Cityscope platform should be vis-a-vis, the right neighborhood. We always show this radar plot, and it's got a pretty strong disposition on what's appropriate. So that's question number one. And question number two is, what I love about the Cityscope platform, and I think something that draws us all to it, is its the way of explaining ideas, or its transparency, at least on the tactile front or the visual front. And part of the thing I've always struggled with is, how do we represent what's actually the data-driven end of it, so that becomes more transparent as well, so that there's this new layer of transparency that creates trust in a system, and just how we would start thinking about how to visualize that or how to represent that to a public.
Yeah. I'll focus more on the second one, because I think it's a good segue to talk about the efforts that all of us, including yourself, were doing in the past few years, which is to take what was a fancy Media Lab project, very shiny, Legos, lights, all of that, and rethink it in a way that is truly open-ended, open source and open-ended, and is possible for development and expansion from other places. I think the example I started with, the project done in Budapest, was a wonderful example. We didn't work on that project. They sent us a mail, said, we built a Cityscope, we did community engagement, would you like to see? And the beauty of that was that, given the fact that this thing was already out there, and they understood that it's no more than a skeleton for engagement processes, they basically plugged their own questions, their own site, their own questions, their own process, and created a whole urban discussion around that. So for me, how to visualize it, I'm not sure, but the fact that it's already sort of created as an open-ended architecture, I think highlights most of the capabilities of different communities and participants to expand into other sources of data or other models of analysis. I'm not sure. I don't know if that answers both your questions, but
yeah, I mean that was a use of it. But I'm curious to know, like, visually, I think it's a longer discussion about how we would represent the back end of Cityscope so that in an engagement process, people would really understand how these radar plots are being generated.
I think we're going to leave that to the metaverse, I guess.
How these, right.
Okay, Luis Alonso, research scientist at City Science Group. I don't know Ariel at all, so so I think the presentation was great. Seriously, this is outstanding. So congratulations, and I think that actually what you are answering now to Marcus is resonating with me, because at the beginning you were making the point about the platform, how it's open source. People can build on top of that. You can have your own like module, etc., etc. But as Esteban was saying, like the presentation was so good that at the end looks like a final product. so it's good that we are refreshing this idea that okay, it is a skeleton, as you were saying, where people can do research, and we have. I mean, the team has been using this not only in urban planning, also with the refugee crisis, et cetera, et cetera, et cetera. So I think it's a super flexible tool. And I think the questions that we have here always is a little bit looking for Ken's and your lead on the future steps. Like, I think Marcus is a little bit asking the same thing, no? Like visually, how can we get into the next step of visualizing data? That's something important. But also, since I know that you are always like looking into next steps. So what is missing? What could be like? It's building on Ken's question, I think. But I think like what could be the next step of the Cityscope? Is this like a final product? Should we spin off this, or should we just move into something totally different? I don't know. I mean, like that's a little bit the.
No, it's great that you're saying it's a final product, because if we go up to the third floor, I guess half of the demos are dead now. And so just to restart them would prove that it's not very much.
No, what I'm saying is that after the presentation looks like a final product.
Right.
Even if
in the video they run, but no. But thank you, Luis. I think it's a wonderful question. Again, there is this level of thinking about the future of Cityscope in a more of a holistic, governmental way. How do we embed Cityscope thinking into early stages of city planning process. From a technical standpoint, what I would love to see is this really becoming a platform, but really a platform, so something that is completely, out there and is like some of other Media Lab projects that grew from a, couple of crazy prototypes to something that is completely useful for many people, and we don't have a direct contact to them. We don't necessarily lead the projects with them. But similarly to what happened in Budapest or in other places, they just take it and run through it, and that becomes their main vehicle for decision making. If that's something that we can do, I think could be our biggest contribution with the Cityscope platform. So that's hopefully where we can next take it.
So I think what Marcus, at least what I heard him asking, was a question about trust, which I don't think is a word you used in the presentation. And without trust, none of this would work, right? We have the indicators, we have the metrics, we have the simulations. In Hamburg, the government, the mayor told me that it was really critical that this platform was put together by MIT, working with a local university that didn't have a stake in the issue, that we were considered a trusted third party. If this was put together by Sidewalk Labs, I'm not sure it would generate a lot of trust, which means making it totally transparent and understandable. So maybe you can address what that might entail.
Thank you. I mentioned Ines, who is a researcher who died. I think she perished 2 years ago, and I read her papers because Iran mentioned that she would be a great advocate for that. She was talking about community engagement, technological community engagement years ago, I think 3 or 4 decades ago already. And she was thinking towards how those urban models would eventually evolve into something by which decision making will take place in cities. And she was also concerned by the question of how to build trust. And what she defined in her text as collaborative participation is the fact that we have total transparency on the tools, the methods, and the questions themselves, and that are open for interpretation and even criticism, creates the majority of trust. Now, we are also aware of the fact that we put open source code online doesn't mean that people will actually go and dive into it and parse it. But to some degree, that creates this first level of trust, right? It's there. If you want, you can do it. And people are becoming more and more well acquainted with these tools today to be able to question some of these parts. But it's also, and that goes back to the citizens expert, involving the members of the community and the members of the of the government and basically everybody that is involved through the creation of the process itself. So not waiting, not creating a Cityscope process, delivering it as a package, but otherwise building it directly with those members from the get-go. So I think these two together can, to some degree, start answer the question of trust. But I'm also, and I think the summary of the fourth chapter was that in some cases it will be very hard to distinguish between a Cityscope that is, just masking participation, kind of optics of participation, and a Cityscope that is truly in participation. And I think that this is kind of still an open question. We haven't yet nailed this one.
Yeah, hi, Ariel.
Yep.
Again, congratulations of this thesis, and I quite agree that it must be the most beautiful presentation I've seen as a thesis.
Thank you.
Yeah, and this is Chance from Shanghai, the visiting students in City Science Lab, and I've been a huge fan of the Cityscope for years. So here I could like to describe the interaction process of the Cityscope, like planners or other stakeholders play or do some changes to the tangible user interface and get feedback from the screen, the indicators on the radar charts, and maybe the 3D models, the heat map on it. So on an abstract level, it's like we are expect some insights from the feedback and the changes we've done. So my question is like, what kind of insights we are expect to gain from the Cityscope interaction? Is it more like a causality, or it's more like a relationship?
Yeah, but I think that touches back a bit on what Esteban was talking about. To what degree, when we interact with the platform and create a transformation or a change to the built environment, can we clearly, predict the impacts of that change? And so I think that if you go and look at what is out there today in terms of companies or off-the-shelf products, hard urban systems is a solved problem to some degree. You can do anything from noise, water, wind, solar, and many other kind of urban analytics tests that will be probably the most accurate in history and will run in real time, and this is pretty much a solved problem. Where I think we're still struggling or otherwise have kind of a blank spot on that chart would be the whole idea of understanding human behavior and more subtle aspects of the built environment. To me, that's the most interesting part of Cityscope, because yes, we might optimize a building or create a generative model that optimizes a building for wind, water, whatever. Does it also optimize for human behavior or for interaction or for the chance of me meeting somebody and having a beer or creating something innovative together? These are to me the most interesting questions. A lot of Esteban's work and Human Dynamics Group work is about those questions. And I think that sort of the holy grail of where Cityscope would eventually end up, Cityscope or Cityscope-like processes would end up, would be the ability to truly predict through those systems what will be the real impact on human behavior given a certain change. Whether we get there or not in this lifetime, I'm not sure, but we should definitely try.
Okay, so thank you, Ariel. This was great. Let's give Ariel a round.